Nutrition science. Vitamins. Vitamins are organic nutrients that are categorized based on their solubility in water. The water-soluble vitamins are vitamin C and all of the B vitamins. The fat-soluble vitamins are vitamins A, D, E, and K. Vitamins are required to perform many functions in the body, such as making red blood cells, synthesizing bone tissue, and playing a role in normal vision, nervous system function, and immune function. To give you an appreciation of the many functions of vitamins, here are a list of vitamins and some of their major functions. Vitamin A is vision, reproduction, immune system function. Vitamin D is for bone and teeth health maintenance and the immune system. Vitamin E is for antioxidant cell membrane protection. And vitamin K is for bone and teeth health maintenance and blood clotting. As you might suspect, based on the major functions of vitamins listed above, vitamin deficiencies can cause severe health problems and even death. For example, a deficiency in niacin causes a disease called Pellagra, which was common in the early 20th century in some parts of the United States. The common signs and symptoms of Pellagra are known as the 4 Ds: diarrhea, dermatitis, dementia, and death. Until scientists discovered that better diets relieved the signs and symptoms of Pellagra, many people with the disease ended up hospitalized and in asylums awaiting death. The following energy-yielding nutrients. The macronutrients, carbohydrate, proteins, and fats are the only nutrients that provide energy to the body. The energy from macronutrients come from their chemical bonds. This chemical energy is converted into cellular energy that can be utilized to perform work, allowing cells to conduct their basic functions. Although vitamins also have energy in their chemical bonds, our bodies do not make the enzymes to break these bonds and release this energy. This is fortunate as we need vitamins for their specific functions, and breaking them down to use for energy would be a waste. Food energy is measured in kilocalories. A kilocalorie is the amount of energy needed to raise 1 kilogram of water by 1 degree Celsius. The kilocalories stored in food can be determined by putting the food into a bomb calorimeter and measuring the energy output. Energy equals heat produced. In the U.S., the kilocalorie is the most commonly used unit of energy and is often just referred to as a calorie. Strictly speaking, a kilocalorie is 1,000 calories. In nutrition, the term calories almost always refers to kilocalories. Sometimes the kilocalorie is indicated by capitalizing calories as calories. For the sake of simplicity, we'll use the term calories and kilocalories interchangeably. Below is a list of energy sources in the diet from lowest to highest calories per gram. A gram is the amount of weight of a paperclip. Notice the addition of alcohol. Although alcohol does provide energy, it isn't a nutrient because it isn't required as a source of nourishment to the body. So carbohydrates give 4 kilocalories per gram Protein gives 4 kilocalories per gram. Alcohol gives 7 kilocalories per gram, and lipids give 9 kilocalories per gram. Carbohydrates and proteins provide 4 calories per gram, and fats provide 9 calories per gram. Fat is the most energy-dense nutrient because it provides the most calories per gram, more than double of carbohydrates and protein. When you look at the nutrition facts panel on a food label, you'll see that it lists calories as well as grams of total fat, total carbs, and proteins per serving. From these values, you can estimate the amount of calories coming from the different macronutrients. Looking at the values in the nutrition facts label, you can convert grams into calories by doing the following calculations. 8 grams of fat times 9 kilocalories per gram equals 72 kilocalories. 37 grams of carbohydrates times 4 kilocalories per gram equals 148 kilocalories. And 3 grams of protein times 4 kilocalories per gram equals 12 kilocalories. You can double check your math by adding the calories per serving provided from fat, carbohydrate, and protein. This number should come close to the total calories per serving listed on the nutrition facts. It will not always match up exactly due to rounding. Organic and inorganic nutrients. There is one more way to categorize nutrients, organic or inorganic. When you think of the word organic, you might think of how foods are produced, with or without synthetic fertilizers and pesticides. But in this case, we are referring to the chemical structure of a nutrient. Organic nutrients. The organic nutrients include the macronutrients, carbohydrate, protein, and fat, and vitamins. An organic nutrient contains both carbon and hydrogen. Organic nutrients can be made by living organisms and are complex, made up of many elements, carbon, hydrogen, oxygen, and sometimes nitrogen, binded together. In a sense, they are alive and therefore can be destroyed or broken down. Vitamin E is an organic molecule because it contains both carbon and hydrogen atoms. Vitamin E is synthesized by plants and can be destroyed by heat during cooking. Inorganic nutrients. Inorganic nutrients include both water and minerals. Inorganic nutrients do not contain both carbon and hydrogen, and they are not created or destroyed. Minerals can't be destroyed, so they are the ash left when a food is burned to completion. Minerals are also not digested or broken down, as they are already in their simplest form. They are absorbed as is, then shuttled around the body for their different functions, and then excreted. Nutrition science. Vitamins. Vitamins are organic nutrients that are categorized based on their solubility in water. The water-soluble vitamins are vitamin C and all of the B vitamins. The fat-soluble vitamins are vitamins A, D, E, and K. Vitamins are required to perform many functions in the body, such as making red blood cells, synthesizing bone tissue, and playing a role in normal vision, nervous system function, and immune function. To give you an appreciation of the many functions of vitamins, Here are a list of vitamins and some of their major functions.